Session 2, Part 2, Valves and Fittings. At the end of this part of the session, you should all be able to state what all fittings used on cold water systems must comply to, and hot water systems as well. Recognise and label each of the valves shown in this session. Identify and describe each of the different float valves. On top of this, what I want you guys to be able to do is be able to sort of know which valves we can use for low pressure systems and which ones we can use for high pressure systems and which ones we can use for both. And also want you guys to be able to describe the differences between the float valves as well. That would be useful to be able to do. So regulations and standards. The main piece of legislation for hot and cold water systems is the Water Supply and Fittings Regulations. These tell us that fittings must be resistant to corrosion and avoid contaminating the water. Some examples of fittings that might do this would be fittings that would contain leaded solder or untreated steel fittings, because they'll start to rust. You can find which fittings and valves are suitable for hot and cold water systems by checking the Materials and Fittings Directory, which is written by RAS. Stop valves. There's two ones that we might sort of need to recognise. This is an external stop valve, which will be fitted at the boundary of the property alongside the water meter. And an internal stop valve, this one specifically would be most likely be fitted on the MDPE pipe as soon as it comes into the property, but we can use stop valves anywhere on high pressure pipework. Okay, and this kind of shows how a stop valve works. The actual picture here is actually of a globe valve, but in terms of the way that the water flows through it, the water kind of goes down and up and through. The main difference is that a stop valve would have a sort of washer and a jumper plate which would screw down into the valve seat, rather than what's shown here for this globe valve. But in terms of the internal workings, the way that it works on the inside, it's got a rising spindle, and the water sort of flows up and through like this. Okay. Drain valves. Drain valves are used for removing water from the system. There's sort of two key places where they need to be installed. All low points in the system, so you can drain water from them, and also immediately after the main stop valve. So straight after the main stop valve, as the water comes into the property, we should make sure we fit a drain valve. Okay. Gate valves, we use gate valves only for low pressure water. It's got a metal gate which drops into a metal seating, doesn't give a great seal, which means that we can only use it for low pressure. The big benefit of it for low pressure is the fact that it actually opens up to the full bore of the pipe, or almost the full bore of the pipe, which will cause minimal restriction to the flow, which is good for a low pressure pipework. You can see an example of how it works here. You've got the metal gate which will rise up and open up to the full bore of the pipe. Okay, so this is a gate valve. Isolation valves or service valves, a lot of people call them quarter turn ball valves. They might be described as spherical plug valves in the test. And these are examples of them here. So quarter turn ball valves. I would call these always Bolifix valves, but instead of these quarter turn lever valves. But yeah, I mean, there's lots of different terminology to use to describe the same things really. These ones here are great. They're full bore. So these can actually be used on your main runs in low pressure, but you can also use them in high pressure as well, because they give a good seal. There's a rubber O-ring in there, and when you turn it sideways, when you turn the lever, that ball turns and it goes across the pipework. It's sealed against the rubber, gives you a good seal. So it can be used on low pressure pipework and high pressure pipework. These, generally speaking, these can be used on low pressure and high pressure, but only used for isolating individual appliances. Okay, so these this little lever one here, this ball fix one here, and this is the symbol for the general symbol for a service valve, just there. Okay. Yeah, I mean, so some of the things you might want to make sure that you isolate for servicing could be boilers or water heaters, pumps, water softeners, often described as water conditioners by City and Guild, and washing machines and dishwashers, as well as float valves, as we've discussed in the last part of this section. These are washing machine valves. They work exactly the same way inside as the service valves we've just looked at. The only difference is they've got a sort of different type of thread on the other end, which is designed for putting on your hoses for your washing machine and dishwasher. Okay, you get different heads that you can put on these, different levers, I suppose, if you want to describe them as that. A blue one if it's on the cold pipe, for example, or a red one if you put it on a hot pipe. And this is how these lever valves work, or these quarter turn valves work. You have the ball inside, which you turn, go across the flow and stop the water from flowing. Ideally, they should be only in the sort of full flow or off position, as sort of if you keep them partially open, it can kind of damage the O-ring of solar further. Okay. Very briefly cover shear stop because it might come up in the test. Shear stop's a very kind of modern valve. It actually uses water pressure to switch off the water. So you push the switch, it uses water pressure to switch off the water. I've tried to research it. I've not been able to find out a huge amount about the internal workings of it, but it's a pretty cool idea, you know, being able to switch off your water with just the press of a switch. It's yeah, it's an interesting sort of innovation. So it's something that could be good for elderly customers. It obviously makes it easy for them to shut off the water if there's an emergency. They don't need to turn these potentially quite stiff stop valves and be able to kind of crouch down and find them and access them. Water meters. There's internal and external water meters. This is a symbol for it here. Internal water meters would be fitted inside the property, obviously. External water meters would be fitted outside the property, normally near the boundary. You can see the sort of meter box for it here. And then occasionally you might get ground breaker boxes, which would be fitted above ground, but outside the property. Okay, so valves for high and low pressure, we've already kind of touched on this. Stop valves we can only use for high pressure. You can see the picture of the stop valve here. You've got the water sort of flowing down and up and then through, and that's the symbol for the stop valve, you might remember from the processes module. Gate valves and can be used for low pressure only, because like I said, it's got that metal to metal seating essentially. So and lever valves or quarter turn valves we can use on both high and low pressure pipe work, like I've already said. Okay, pumps. Occasionally you might need to fit a booster pump to a cold water system. You can get something called accumulator pumps, which can be used if you've got low incoming mains pressure, or potentially if you've got an indirect cold water system, you might want to use a pump to boost that water. It is worth noting that anything that draws more than 12 litres a minute, even if it's coming from a storage system, you should inform your water supplier and get the okay from them before you fit it. Okay, and this is a symbol here for a pump. Pressure reducing valves. If the water pressure is too high, you can use a pressure reducing valve to reduce the pressure. Interestingly, generally speaking, if you reduce the pressure, you'll also reduce the flow, because the pressure is kind of what pushes the water along. And you can see the pressure reducing valve symbols just here. It's got like one big side and one little side, which kind of shows the reduction in pressure. Blending valve, mixer valve. You'd use these to make sure that the water temperature that comes out is safe. This is sort of something that we need to think about probably in hot water more than in cold, but obviously it's got a cold side which goes into it. Key bit of information that will be useful to know, mainly for your hot water module. Baths have got an absolute maximum set temperature of 48 degrees C that should come out of the tap for safety to prevent scalding. And to ensure we achieve that temperature, we would use a blending valve. Okay. One of the things worth noting, in a blending valve, you should fit a single check valve on the inlet and on the outlet. And you can kind of see how it works here. As you turn the handle, it sort of moves and it allows either more hot water in or more cold water in as appropriate. Float valves now. A symbol for a float valve is just here. As you can see, it looks just like the valve itself. And these are used to control the flow of water into storage systems or WC systems. They will need regular maintenance, and we're going to look at that a bit later on, actually next week in the next module. And these again can be fitted on high or low pressure pipework. They would have something inside, a flow restrictor inside, potentially for Torbecke valves, or in the case of part 2 and 3 float operated valves, they would have a different sized orifice which would be changed depending on the water pressure. You can see this top one here, this red one, it's got a bigger hole in it, a bigger orifice essentially, and you'd fit that on a low pressure pipe because it's going to cause less restriction to the flow, allow more water to flow through it. This one here with the smaller hole, you'd fit that on higher pressure pipe because it's going to cause more of a restriction to the flow, so you don't get too much water flowing in out the valve and making it noisy essentially. Okay, all float valves have to meet the requirements set out in BS 1212, and they describe 4 parts. The BS 1212 has 4 parts which describe 4 different types of float valve, which we're going to look at now. Okay, so the part 1 float valve, or the float valve described in part 1 of BS 1212, this is the sort of original float valve really, and it's pretty simple. It's the only one that's got the outlet at the bottom, and this is essentially means that it's more likely to be at risk of backflow. So we shouldn't fit these anymore from new. You are allowed to use them to replace them, like for like. If you go to a house which has got one of these in the loft, in the attic tank, then or the attic cistern, then you could replace it like for like. That wouldn't be a problem. But you should not fit one of these from new. Okay. They're made of brass, like I say, and the outlets at the bottom. So that's the sort of key sort of features for our BS 1212 Part 1 float valve. For BS 1212 Part 2 float valve, you can see it actually looks quite similar. It's also made out of brass. But you can see the outlet for it is actually at the top. The water goes up, round and out here. Interestingly, it does work differently on the inside from the Part 1 float valve. It's quite different on the inside. We'll look at that again, like I say, when we look at sort of float valve maintenance in session 3. But it's brass. Part 2 float valve is brass. It is the outlet at the top. Key features. Okay, visually. Yeah, and interestingly, the Part 1 float valve, it doesn't have any sort of built-in means of adjusting the water level, whereas with the Part 2 float valve, it has a means of adjustment. The float valve would be fitted on this part here. You can see these threads here that I'm pointing at with my mouse, and this has got a little sort of grub screw on it that you can, once you've screwed on the float valve, you can sort of move the height of the float up and down along this this riser. Okay. Part 3 float valve actually works exactly the same way as the Part 2 inside, but the key difference is it's made of plastic. It also has a means of adjustment. If you look here where I've got my mouse pointer pointing, if you move that screw up or down, if you move it up, then it will, as the valve arm rises, it's going to push on this little piston here, which will push on the diaphragm in there, and it will shut it off much more quickly. If you move it down, then the valve arm will rise more before it shuts off. So it's got a means of adjustment, which all float valves, all modern float valves must have. Okay. Part 4 float valve, also known as an equilibrium type float valve, sometimes also known as a Torbeck type float valve. They're designed to work with higher pressures. Okay, they actually allow a little bit of water through the washer, which means that the water pressure on both sides of the washer are equal, they're the same, so they're kept in equilibrium. That's why it's known as an equilibrium type float valve. And because the pressures in equilibrium on both sides of the washer, it actually means that it takes much less force to switch it off, which means that the lever arm, you notice the lever arm on a part 4 is much shorter than any of the other ones, and that's because the water pressure each side of the washer is in equilibrium, is in balance. It doesn't take very much force at all for it to rise and switch off the water. So you can use a smaller float and a smaller lever arm. Okay, now it is time for your task.